Good morning, everybody. Our next question is perform the inverse Z transform using residue MATLAB function. So what do you mean by residue function and how do we use it? We can simply write in MATLAB help residue. As soon as we write this, we get the help. How do we use this? Basically, what is residue? Residue is the partial fraction expansion. Suppose we are given a polynomial of b and a. So with the help of the residue function, we break it into r. R is the residue, p is the poles, and k is the constant coefficient. Fine. We can use it for with when k can come constant, with repeated poles also, as well as with imaginary poles also. So let us see how do we use this. We try our first function. We take a simple function, we try it with that function. See, this is our first question. To perform the partial fraction expansion on dz, dz means that it is in z domain, 4z plus 1 z square minus z minus 2. So let us see how do we do this function now. It is very easy, as we have already seen in MATLAB help. How do we do it? First of all, we enter the numerator part. Numerator coefficients in a square bracket, it was 4 and 1 and a semicolon. Next we add the denominator values, which is equals to square bracket 1 minus 1 and minus 2 bracket closed and enter. Fine. Next we write the syntax which is given here in the residue help command, which is r with the residue, p is the poles and k the constant, which is equals to, now we use the command residue. Again, I'll write the brackets and the variables that I have used here. So in round brackets, I'll write here numerator, num, comma denominator, and then enter. You would find here I have got values 3, 1, 2, minus 1, and a matrix with no values. Fine. So what does it mean? We have broken it a partial fraction. Let us see again how have I done this. I have taken the partial fractions here, broken it, and I get an answer which looks like this. See, I have written here, this tells us that this equation 4z plus 1 upon z square minus z minus 2, it looks like 3z minus 2 plus 1 by z plus 2. So this is how we do it, the inverse Z transform using the residue method. Similarly, suppose we need to find the residue command also work when poles are complex. So suppose this is the function that is given to us. We can similarly find the inverse. So this is the assignment that you have to do. Another question you can also take. This is the example. Here is another example. This is for the repeated poles. So this is 2z plus 1 upon z cube plus 5z square plus 8z plus 4. So this is how we use the residue command. Thank you.